Alright, Math 3, looking at some arithmetic versus geometric sequences. First thing we want to do is just quick remind ourselves some vocabulary, some things that we're used to seeing. First I mentioned that this a sub 1, alright, the way you read it is a sub 1. A sub 1 is talking about the first term, okay, a sub 2, second term, third term, fourth term, of course. And you got here to a sub n. A sub n is just a fancy way of saying it's the nth term. Most of the time, the nth term is what it is that you're looking for. Maybe it's a 100th term, maybe it's the 50th term. We also use that whenever we're writing our equations. If we write something in terms of the nth term, then what we're saying is that's the equation or the formula that we're going to use. So keep that in mind. Review from last week. D stands for common difference. Of course, that only works on arithmetic sequences. And you always find the common difference just by subtracting those two. And then you've got your geometric sequence, which has a common ratio, where you divide the first two terms. Alright, so that's just a review from last week. We're going to look real quick right here. A sub n, the nth term, in other words, our formula, the nth term for an arithmetic sequence can always be found using the first term, a sub 1, plus, we're going to take our natural numbers, minus 1 every single time, times the common difference. Now, this is really just an extension of what we call point-slope form. If you remember point-slope form, we solved this on the board. This is a line. This is point-slope form of a line. Here's your m, your slope. X is right here, plus b, mx plus b. So this is really just a fancy way of doing linear equations. But anyways, if you'll use and practice this, it's pretty straightforward. You can see the common difference in this term is a 7. And once we know the common difference in the first term, it's pretty easy to write in a formula. Fill in the blanks. And then do a little bit of simplifying. And our formula for this particular sequence would be 7n plus 2. 7n plus 2 would be the formula for this arithmetic sequence. Now, why do we like that? Because to find the 100th term, all I got to do is plug in 100. Of course, that'll give you 702. Alright, for the geometric sequences, I hope you recognize how closely related this is to a exponential. Look, a, b to the x, they really are so very close to the same. And if you remember what the graphs look like, it is exponential. So like before, a sub n is the nth term, a sub 1 is the first term, and of course r is your common ratio. So we find our common ratio, and we figure out the common ratio here is times 4. So 4 is the common ratio, that's our r. We plug in our numbers here, and we got a pretty straightforward formula. There's normally very little simplifying to do. So there's my formula, and now if I want to know the 10th term, I can just plug in a 10. Alright, if you got any questions, let's go back and look at those again. Now what we're going to do is, what if I don't give you the first term? Alright, so here I'm going to give you a situation where I don't give you the first term. I give you the 5th term instead. Well, think about that for a second. If I give you the 5th term and the common difference, you could easily keep going up. Well, why don't you just go backwards? Instead of doing up 6, work it backwards 6. Until you find that first term. Now, there are other ways of doing it, but really, why not just use our sequences? Now you know it. Fill in the blanks. Distribute and combine your like terms to come up with the formula that'll show it. And once you have a formula for, we call that an We call that an explicit formula. Once you have an explicit formula for this, you can use that just to plug in 100 to find your 100th term. Works exactly the same over here on a geometric. Notice if I give you the 4th term, if the term's close enough to the front, just work it backwards. This one has a common ratio of 6, so if I work it backwards by dividing by 6, I can figure out that A1. And once you know A1, you just use your formula. And of course, once you have a formula, it's easy just to plug in to find the 10th term, plug in a 10. Alright, one of the best applications we have for these are when we want to find the sum. Okay, so I've given you 2 formulas here for the sum. There's actually another formula for the sum of geometric you can look up, but I use this one because they both have the same information. They both have the first term and they both have the last term. By the way, a sum is generally called a series. So if you see this word series, then that's what it's asking you. It's asking you for the sum of a series, sum of a sequence. So I look here, A1 represents the first term, A sub n is going to be the last term. So if I know the first term and the last term, it's easy to find the sum. So I'm going to use this situation here. My first term is 20. That's pretty straightforward. On the 15th row, I have to figure out my last one. So I used my formula. I used my formula we just practiced above, and I plugged in a 15. And I found out that there must be 62 seats in that 15th row. So now you know the first row is 20, and the 15th row is 62. And then you can just use your formula. And of course that shows me that there are 615 seats in the whole theater. I know I'm going fast, trying not to waste your time, but if you guys can hit pause anytime you need to. Over here, here's another situation. Alright. We know the first term, we know there's 5 people. To find the 8th term, I'm just going to use my formula that we just practiced from above. Find out that there must be 390,625 people for that 8th term. Now that you know your first term and your last term, I already know my R is 5, so I can go ahead and fill in my formula. The sum of the first 8 terms ends up being 488,280 people. Now in this particular situation, I would also want to say that you probably got to add one more back in, right? The original person. Alright. Got some practice problems on the other side. Give it a try, and we will see you tomorrow.